Okay, so for this question, it's dealing with graphs again, something you might not be used to as much, but let's just work through it. So the first thing you should notice right away, this is a second order circuit that's a parallel second order circuit, right? So we're gonna have to do something with that in those equations. Another thing you can notice is that these are just damping curves, right? We learned about them in class. And even if you forgot, you can kind of infer what they are, just what they look like. This one obviously jumps too high, just kind of, it oscillates a little. You can tell that's underdamped, right? It's not damping properly. It's like doing whatever. This one, it damps really fast, and actually it's like inching up slowly at the end. So this is probably overdamped, right? And this one is in the middle of the two, right? So this is the black one is probably the critically damped, right? So now we just have to find which damping curve we are. So how do we do that? Well, all the damping, again, depends on alpha and omega, right? Those are the two that determine that. So let's find those. So again, going to our trusty cheat sheet, we have this type of circuit, which means we are going to be finding alpha like this and omega like this. So let's just plug in. All right, so we got alpha is equal to 1 over 2 RC, which is equal to 1 over 2 times our resistance, which is 10 ohms, and our capacitance, which is 50 nanofarads, which is equal to, you can plug it into a calculator, you'll get 1 times 10 to the 6th, I believe, yeah. All right, now let's find our omega naught. So that one's just going to be 1 over the square root of LC according to our cheat sheet, right? So that's going to be 1 over the square root of 20 microhenries and 50 nanofarads. Again, we're getting these just from these values over here, right? And that is equal to 1 times 10 to the 6 second times 1. Okay, what do we notice? These are the same thing. So when they're the same thing, what does that mean about the damping? That means we are critically damped, all right? So we know we're critically damped. And again, which one did we say was critically damped? C, right? So easily we know that this answer is C.